Hello, everyone. Good evening. Thank you to each and every one of you for being here with us today. Welcome to day one at Globant QuaNTA NXT, Globant's premier quality engineering and automation web conference. I'm Deepa Churi, and it's my pleasure to be your host for QuaNTA NXT. In its fifth edition, we are thrilled to focus on generative AI powered quality engineering. So, without any further ado, let's invite Shivraj Chable, head at Globant Asia, to share his perspective and present Globant to the audience. Welcome, Shiv.
Good evening, everyone, and welcome to this amazing web conference for 2023. We have had a string of amazing successes when it comes to Quanta Next, and I'm very happy to welcome you back to this amazing event. This year marks a very, let's say, milestone year in terms of what we want to see as part of this event. For the last few years, we've all been talking about transformative projects, transformative programs, and we've also been talking about reinventing digital and reinventing domains. This is the year where a lot of that gets expedited and becomes center stage for many companies, for many organizations. The reinvention is going to be a reality. Earlier, there was a huge push from a domain perspective to really try and change the way we were thinking about the business. But at this point, the technology is at the forefront of driving a lot of that invention. What I'm talking about is, again, a lot of generative AI, a lot of AI, and a lot of metaverse. A lot of these have built up to an extent where now we can see technology truly driving the reinventions that we will see in the next 10 years. The question is, are we ready as companies, and are you as individuals, as engineers, ready for this reinvention? We keep talking about AI, and probably in some of our videos, you'll realize that it's not just about understanding AI, knowing AI, or knowing much about what machine learning is, than actually the ability to understand what impact it will have on your product lines. Have you, for example, taken a small break from your regular work and tried to truly reinvent and rethink the product ground up that you're currently working on? So maybe you have a certain product that you're currently working on. Maybe take a small break. Maybe start thinking, if at all I had to introduce machine learning, if I had to introduce generative AI, how would my product look like? And that is very, very important. You need to start thinking in that aspect. You need to start thinking, how can I create a big impact with these new technologies on the customer? What it also does is it explodes the opportunity, explodes in terms of opportunities that you have for new avenues for revenue. For every business, generative AI is not just about creating another fancy web application or fancy mobile application or another fancy interface with the customer. This is going to be an opportunity to truly add those new avenues for revenue and reinvent their whole business process thinking. So this is an opportunity for businesses. At the same time, you need to be ready for the new challenge. We have seen these changes in terms of sports. We have seen these changes in every aspect, in media, entertainment, every aspect that we see around. When that is happening, the people who are successful have always been the people who have been able to adapt. So I think I want to congratulate all of you to come here, invest your time on a evening when you could be really in usual calls and really getting busy with work, but you're spending time investing in yourself. So I want to congratulate you for taking the first step towards reinventing yourself. I think once you reinvent yourself, once you start thinking about the business impact with all the new technologies, you're truly going to uh, be relevant for the next 20 years. So welcome to this amazing web conference. I think you're in amazing hands. I don't want to take a lot of your time. All I want to do is be as
and you're improving on the cost.
with all the new technologies. You're truly going to uh, be relevant for the next 20 years. So welcome to this amazing web conference. I think you're in amazing hands. I don't want to take a lot of your time. All I want to do is be as participative as possible, ask as many questions as possible, and then most importantly, once you go back from today, this is going to be more food for thought. We are not going to be able to give you solutions today, but what is important is you start thinking about these things. You go back, you start reimagining your products that you're working on, the next product that you work on. How will you reimagine them? That's very, very critical. So I'll leave you in capable hands of Anagha, Ayan, Piyush, and Gaurav and the whole team. I think they've lined up some amazing talks and amazing content. So congratulations on this, on attending this, and I really look forward to an amazing series this year. Thank you so much. Have a great day. Bye.
Thank you, Shiv. After an amazing yet truly informative introduction, I'm sure your appetite has now worked its way up. Let me present Anaga Pawar, Technology Partner at Globant, for the keynote address.
Start getting them mission confidence.
Thank you, Shiv. After an amazing yet truly informative introduction, I'm sure your appetite has now worked its way up. Let me present Anaga Pawar, Technology Partner at Globant, for the keynote address.
Good evening, everyone. I'm thrilled to welcome you to Globant's Premier Quality Engineering and Automation Conference, QuaNTA NXT 2023. Today, I'm here to talk about how generative AI is emerging as a game changer for testing domain. We know that the technologies are changing rapidly. We know that the systems, applications are becoming more and more complex. How is generative AI helping us in all of these testings? So, in my keynote today, I'm going to be talking about what is generative AI, how the applications are getting generated for it, and what are the benefits for it. So, what really is generative AI? We all know and we have all been talking about it. It is nothing but a branch of artificial intelligence where we generate new data depending upon the old or historical data. It basically finds the patterns and it comes up with new generative data. That is nothing but generative AI. Now, what are the applications and the frameworks? Again, we have seen them, we have used them like image recognition, we have used them in automation for auto healing capabilities. We've used even something like ChatGPT, where probably if you give them a web service, it is going to give you the test cases for it. So, even these tools are coming up with these generative AI applications. What are the benefits out of it? Well, again, time, the biggest benefit out of that. Then the quality is improved because now you get to focus on more complex or more corner use cases, which probably you may have missed out earlier due to time. And then the quality also, because it's the same thing, you get to focus on things which is more relevant, and you will be able to work on more complex cases. So in short, with these generative AI, you're saving on time, you're saving on quality, you're improving on the quality, and you're improving on the cost efficiency also. So, can I conclude that yes, generative AI is definitely changing the landscape for software testing? Yeah, it is there. It is meant to be here. But does that mean that we have to be afraid or we should not be using it? No. What we need to do and understand is that how we can use the generative AI applications, tools, frameworks for improving on our quality testing. We need to start getting them integrated. It does not mean that I need to understand what are the data algorithms or what is LLM or what is data engineer do. No, I need not understand that. All I need to understand is how can I get it integrated with my testing activities. With this today, I'm confident that we can say Today's conference is going to cover all of these different use cases of these applications. And I hope that you'll get more insights into how generative AI has been a game changer, like I said earlier, into the software testing domain. Thank you.
Thank you, Anaka. That was an insightful and thought provoking take on generative AI. Ladies and gentlemen, our first speaker for today is Devesh Chanchlani, founder and director at GoCloud. GoCloud is a group of high potential tech wizards who collectively have a close to a century of experience in this ecosystem of IT consulting, product engineering, and services. Devesh will give us insights on dealing with the API chaos. Welcome, Devesh.
Hi, all. Welcome to this exciting session on dealing with API chaos. Um, as most of us would have worked with APIs, so it is not easy to work with APIs, especially in an enterprise software development world. We are continuously building APIs, we are integrating them with other APIs, we are orchestrating them, we are managing them, we are deploying them, everything in an integrated fashion, in a continuous fashion, in a steady speed, and we don't want anything to hamper our speed or take any moment away from our time to market. And which is where you know keeping a very efficient approach working with APIs is very significant. As the APIs grow, especially in an enterprise world, you know the challenges related to the APIs become tremendous and they cause a lot of chaos. So here in this session, we will try to understand what are those problems that manifest into chaos and how we can deal with them by using some modern practices, wherein which are also very proven, wherein few other enterprises have tried them and they have carved out their own success stories. So let us quickly deep dive into this exciting session of dealing with the API chaos. Welcome again, folks. So before we dive into, I will take a few moments from you guys to introduce myself. Hi all, I am Devesh Chanchalani. I am a technology enthusiast and a hands-on coder. I have worked with ThoughtWorks in the past and I am an XP evangelist. I have trained over 1,000 professionals on agile technical practices, especially around continuous delivery and extreme programming. Um, I am also an entrepreneur and a travel freak. I founded this company called Steerlin in 2016. That's an IT services company. I started another company last year called GoCloud, where I'm head of technology, and we are trying to solve a lot of exciting problems for our customers. The latest one being around generative AI. So if you guys are also excited about generative AI, feel free to uh, connect with me on LinkedIn and say a hi. Would be very happy to chat with you guys. So moving on with the session. So API chaos. What is API chaos? So so if we talk about any API, it has two parts to it: the producer of the API, and the consumers of the API. So every story will have two sides to it. In APIs also we have got two prominent sides, which is the producer side and the consumer side. If you look at the producer life cycle, it's like trying to understand what we are trying to solve, designing the API, developing, testing, securing them, deploying them, observing how they are performing, how stable they are, and finally distributing them. And then comes in the consumer, The consumers discover the facilities or the features that the API is offering. They evaluate it. They try to integrate it with their own internal systems, test it, deploy it, and observe it. If everything is stable or not, and then the cycle goes on and on. So this is an iterative approach. So producers come in, they bring in new features, new value adds through their APIs. Consumers want to integrate those value adds, those features, and build their applications on top of it, more evolved offerings. And this is how the cycle goes on. These can be third-party APIs, which the consumers are consuming, uh, possibly by other vendors or partners outside their organizations, or these could be, you know, teams within the organization or the big enterprise group itself, that are churning out APIs, which the consumers are using, making use of, and enhancing their applications. Now, uh, where are the challenges that we see in this entire life cycle? So I see a lot of challenges, but particularly around the later phases of the life cycle. For example, the producer team may be churning out APIs, but later they may observe, or at the time of distribution, they may come to know that there is a gap between what was promised, or what was expected by the consumers and what they're finally churning out. These could happen with new APIs that they're churning out. So if they wanted to churn out a certain API with a certain um, uh, specs, but the final outcome is a little different, or while they are rolling out upgrades. So while they are rolling out upgrades, after the upgrade, the specs um, you know were, were different than what the actual was, than what the earlier definition said, or when they are carving out new versions and things like that. Similarly, on the consumer side of things, the issues may arise once they start integrating the upstream APIs with their own systems, with their own applications, with their own API um, environments, and then at the time of integration they may see the challenges out, and then they may figure out, okay, this is not working out. But then it might be too late in the development cycle, because now they have to go back to the producer and tell them to make the amends after they have been through a significant part of their own development. So these are the challenges that complicate the entire scenario. Also, because these challenges are propping up in the later pieces of the life cycle, they complicate the process. And if the lines of communication between the producers and the consumers are not very transparent, are not very active, then the problems become even more tremendous. So what can we do to work with such chaotic issues? What if the best thing is, what if we were able to figure out the problems even at the start of the life cycle itself? If instead of finding these problems in the later stages of the life cycle, if I would have, as a producer, I would have been able to find this problem much earlier, it would have been a boon for me. Similarly, for the consumers, if they would have identified these problems much earlier as they would begin to consume or consider to consume a certain API, that would have saved them a lot of time and a lot of money. So let's dig deeper, into the API chaos. So if I look at the API chaos, I have segregated into, again, the same two facets: the producer side of chaos and the consumer side of chaos. So one of the main points when it comes to producers is, when they are rolling out new features for new consumers, but the new rollouts start affecting the earlier consumers, because the earlier consumers were what the earlier consumers were using. Now the API has deviated away from it, and it is causing a problem and crashing the system or the applications of the old consumers. And and that is not a good sign because we want to grow, but not at the cost of our earlier patterns or people who are already using the APIs and have a stable system in place. So so one of the biggest priorities for the producers of the APIs is their new rollouts should not affect the existing or the earlier consumers. Okay, so another one is, when producers want to support multiple versions of the same API. Personally, I'm not a big fan of supporting multiple versions, simultaneous versions of the same API, because that leads to a string of other anti-patterns. But let's say there can be certain situations, sometimes in the financial domain or other critical domains, where your consumers do not want to upgrade or make any changes to an already running stable system, and you as a producer want to support more consumers and expand your capabilities of the APIs and want to roll out a new version, maybe which is more secure, running on a more upgraded platform. But then there will always be some consumers that cannot readily upgrade or may need some time to move to the new version of the API, and hence supporting multiple versions of the same API may become a challenge, particularly when you want to keep the same code base. You would not like to fork out your code base, and each version will have its own code base. That is a very, very problematic thing. So you want to stick to the same code base, but have multiple versions of the API. And in that case, it can be a little tricky when you want to maintain the parity with the older versions and support the new ones simultaneously. Now, the other one is, when you want to roll out new API version versus maintaining backward compatibility. So what does this mean is, you want to take a call, whether you want to keep backward compatibility or you want to roll out a new API version. Because if you want to roll out a new API version which is not backward compatible, or you assume that was backward compatible, but once it is rolled out, now you figure out, it is deviating a lot or deviating away in such a fashion that it breaks the compatibility, breaks the parity. Now that is another challenge, because then that restricts you to move forward. Another is, a similar point is, you detected backward compatibility, but it was too late in the life cycle. So as we saw in the earlier slides, in the producer life cycle, the backward compatibility is detected at a very later stages, when the consumers are ready or they have already started consuming your API, and then they see that their systems are crashing, your API is not good enough um, to be integrated, uh, because of the backward incompatibility issues. So of course, always, rolling out new features without affecting existing end users will always be problematic for the producers, and that is their top priority as well. And they have to make sure that they are always rolling out versions which have non-breaking changes, and which are always welcomed by the consumers, loved by the consumers. Now, moving on to the consumer side of things. Sorry, I took a quick water break. So on the consumer side of things, if you would see, the challenges are, you know, that we come to know only in the integration phase, that the API has issues and we are not being able to integrate with them. So for example, there are these three apps they came across, build, test, UAT phases are complete, but when they come in the pre-prod environment, let's say they are integrated only in the pre-prod environment, and when they reach here, they figure out that the integrations are failing. And and such an issue is going to be very, very costly, because firstly, you are you are discovering it at a very, very late phase in the development life cycle. And the other thing is when this integration issue occurs, which side has the problem? I am sure a lot of you would have come across such conversations, such discussions, such arguments between the consumer team and the producer team, hotly discussing who is wrong here, who needs to create the fix, because the consumers would say the producer side of the API is not giving expected results, the and the providers would say, that the consumers are not integrating correctly. So this is always becomes a hot cake, and it is a big contention point. But more than that, discovering it late in the life cycle is always going to be detrimental. Another issue is, in the essence of being more effective, all the consumers would like to work in parallel. Nobody would like to wait for the providers to be ready, for the upstream APIs to be ready, 100% ready, and then they would start with their own development, because everybody would like to make the most of the time, and they would like to continue in parallel. So generally what we do, mostly is we create service mocks or service stubs, and start working on our own services, writing test cases, and carving out the implementations. But what if our mocks or the stubs that we have created, they are not in sync with the upstream API specs or the provider API specs. And in that case, there's a gap between the actual API that you're going to get at the end of the day versus the stub that you have at hand. Because the gap is there, it will also manifest in your implementations, and your implementations will be buggy, will have integration issues later on, and there'll be a lot of mess. And then there will be a lot of arguments as well, wherein you would expect one thing from the consumer, from the provider, and you will get something else. So that is another issue that would cause a lot of chaos. Another issue is, fear of upstream API upgrade. So what is upstream, what is downstream? Let's have a quick look around it. So if you would see service A, so this is the user interface. Let's say it calls service A, service A calls service B serves service A, provides serves the request and provides them responses, and likewise service A provides responses to the user interface. So in this context, the consumers are downstream and the providers are upstream. So the fear is, if the upstream API upgrades happen, so let's say there are some so the providers are upgrading their systems or upgrading their APIs. And what would this mean? Will this mean, once these APIs come into play, will it break our existing stable systems? Because there is no change on the consumer side of things. The only change is from the provider upgrades. So the provider APIs are upgrading, consumer systems are intact, or so in an enterprise world, everything keeps changing. There are a lot of moving parts, and everything keeps changing simultaneously. But let's say, for the sake of argument, let's say the consumer systems have not changed, and the only thing that has changed in the entire system is the third party API upgrade that has happened, which we are consuming. And suddenly the system crashes, or there are unwanted bugs, and nobody has any clue why these bugs are there. And then some keen architect points out, but there are upgrades in the third party system. And but it is not very straightforward to address where is the problem, to pinpoint where is the problem. And that causes a lot of chaos, because that will need a lot of debugging, a lot of testing, a lot of hunting of the environments if the environments change, or or if something else has changed, because there are so many moving parts, everything keeps on changing. And in an enterprise setup where there are multiple such big systems, interacting with each other, integrating with each other all the time, it is not a very easy problem to solve. And it vastly impacts the enterprise as a whole, because if one system comes down, it impacts the release progression of other systems and other complicated issues. So which is where, these problems, these small little problems, they become very chaotic and go pretty much out of control, and make the situations very, very messy. So basically, new or silent upgrades of the upstream APIs may cause unforeseen failures for the consumers, and this may also include what the consumers are expecting as the final API specs, but their stubs are deviating away from it, or the vice versa. So these are the notions of a lot of API chaos that happens. So, but why is this API chaos happening? Don't we have something that defines the API? Definitely, we have got this de facto standard in the IT industry called the Open API. So everybody, I'm sure everybody, 99% people here, would be now using Open API specs to define or document their API. So, for example, an Open API spec may look something like this. What you see on my screen right now. So here's this API endpoint. Here's some input path parameters. Here's the request body. Here are the responses. So it's a very simple yet very exhaustive mechanism of elaborating or documenting your APIs. So definitely these APIs are there, but then what is the issue with these? The issue with these very exhaustive, well-written open API specs is, at the end of the day, they are still documents. They are, you cannot, there is no mechanism to validate whether your APIs are adhering to these specs, whether your stubs are adhering to these specs, or whether the newer versions are backward compatible or not. So in essence, what I'm saying is, these are simple document API documentation. This is a simple API documentation which lacks automated mechanism to tell us whether the provider APIs are adhering to their own API specs or not. Okay. Whether my consumer stubs are adhering to the upstream API specs or not. There is no automated mechanism. This is just a YAML file, that is used for documentation. There is the new API upgrade backward compatible or not? So these are the three major problems that we will see off and on, and there is no automated mechanism to tell us if these things are happening or not. And think about it: if we get an automated mechanism that addresses these issues, this will save us a lot of time and effort. So let us see how Specmatic tries to solve this problem. So how Specmatic tries to solve this problem is, Specmatic takes in the Open API specs as an input, let's say, and and what it turns out is, it uses the same Open API spec, and 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 considers this as a contract test, and runs it against the provider API. So for the provider, it would create an Open API spec, and it would create contract tests based on its Open API spec, and automatically test whether the provider API is adhering to its own API definition or not. On the consumer side of things, it helps us create stubs or validate our stubs against the Open API specs, against these provider API specs. Um, so when we have written stubs, we can validate whether they are in sync with the provider API specs or not. And if they are, then we can use them to virtualize the provider service and continue with our testing in the lower environments, or use them while we are developing on our own local machines without bringing up the provider APIs. And that also speeds up the entire development time, because now on my local laptop, I need to only bring up the provider API stubs, and these stubs are reliable. They are reliable because they are based on the Open API spec. Okay. And I can simply bring up the provider API stubs, and that is a very, very lightweight process, and I can continue with my implementation on my local laptop versus trying to point to the provider APIs on a test environment and then trying to do the implementations. And what if the test environment is down? What if the provider API is not of the accurate version, or it does not reflect the current state of the provider API, things like that. So I don't have to worry about it. I just have to make sure that I am referring to the latest Open API spec of the provider, of the upstream API, and my stubs are validated against them, and then I can continue with my implementation. Not only that, I can now also run my API test cases in a much faster way. Another is, Specmatic also provides this capability of comparing two versions of the same API. So let's say earlier it was version 1, and now we are trying to roll out a new version, which is version 2, and we can run a compare on it very quickly and come to know whether they are backward compatible or not. And this will quickly tell us if they are backward incompatible, and we can make those changes. The providers can make their changes themselves, you know, before even consumers pointing them out. Even better, as soon as they carve out, they have to roll out a new API version, they just carve out the new Open API spec and just run Specmatic on top of it. That's it. And they would come to know whether that's a good indication or not. If it's a good indication, they can go ahead and carry on with the implementation. So so that's in a nutshell what Specmatic enables us to do. So now let's get on to the more interesting part on exploring these three facets. So the first one is running using API specifications themselves as contract tests. Okay. So let me take you guys to this Swagger page. So this is the Swagger editor. So here I have the Open API spec open for this order API. I'll take a quick water break. Thank you, folks. So uh, so here you can see, on my so we have got about 10 endpoints here, and we've got the Open API specs here. So what I have done is, let's say, so this is a Spring Boot based service. So as you can see on my screen, so we've got Order API service. This is a Spring Boot based application. So in the Spring Boot based application, what I have done is there is this POM file. So we have integrated Specmatic. We have used the Specmatic libraries, under test scope, to write the contract test for our order API. Then we have created a specmatic.json, which resides in the project root folder. Here in the specmatic.json, you can see the reference to the Open API spec for this API. So here you can see the Git location where the Git repo where this resides, and then the path within the Git repo. And here we have the contract test that we have written. So if you would look at the contract test, which resides here under the test folder, so if you would see, this is a very small, simple file, hardly a few lines, and most of it is very boilerplate code. So it extends the Specmatic JUnit support class. And what it essentially does is this contract test, when run, it would bring up the Spring Boot application and run it on the local port 8080. Okay, and we'll run all the test cases. Okay, let's quickly see what it does. So let's run it. Cool. So as you guys can see, about 14 test cases have been executed and all of them are passing. But wait a second, where are the test cases? We have not written any test cases. Do you see any test cases here? Basically, that's the only thing we have. So we've got the contract test, a small boilerplate kind of class, and then we've got specmatic.json. But from where are the test cases coming? So what Specmatic does is it weaves its magic around your Open API definitions. So from the Open API definitions, reading those definitions, it automatically carves out tests and basically uses the Open API definition as test cases called contract test and executes it against the API. As simple as that. So there's a little bit more to it. What else it can do? So let's say you want to do a more detailed testing. So what you can say is you can ask Pragmatic um, to introduce some generative tests. So to generate some more tests, so basically we can say this flag as true and run it and let's see what happens. Okay, very cool. So Specmatic, so about 44 test cases were generated by Specmatic and were executed. All of them are passing, thankfully. So what it does here is, if you would see, there are a bunch of positive test cases here, and then there are a bunch of negative test cases below. So Specmatic runs them as positive and negative test cases, looking at the examples or other stuff in your open api specs. It creates various permutations and combinations of the test cases and executes them. So for example, here a valid id was used, here an invalid id was used, which was called out as an example in your open api spec. Like for example, if you look at this, this is the this is the invalid id 344 that we have mentioned here, and in this products path, and when we are giving this 344 as an invalid id, we are getting a 404 error. So these are the test cases that Specmatic automatically figures out and generates them and runs it against your application and tests it. Similarly, there are other small little examples. For example, in this request parameters, if you would see, is like, so there'll be a combination of values for these two request parameters. So here the name is null. Here, there are values for both type and name, and here you would see type is provided a null value, and if it is a non-nullable field, you will get a 500 such error. So that's how Specmatic generates all those tests, and you don't have to do anything. You have to make sure your open api specs are accurately written and they depict the very nature of your API. Because another issue that we have seen with the producers is their open API specs are not updated. The ones that are even published on their on their public websites, they are also not updated. But that causes a lot of pain. So everybody has to make an effort that their open API specs depict the current API and are always updated, and that will help you to get contract tests for free. So, okay. So moving on to the next one. So contract based smart stuff. So now let's look at some uh, consumer. Okay. Okay. So let's say we are trying to consume this products API. Okay. This product API has a few endpoints, and that is how it looks. So what we'll do is, let's say we have created a stub for this. So uh, let's say this for this products.yaml, we have created a stub inside products understood data folder, and that's the products.json. So if you would see, it has an HTTP request, and then has got an HTTP response. In the HTTP request, you can see this path defined, there's method defined, and there's this request body defined, and this is what you should expect as the HTTP response. And it should adhere to the products.yaml, which is the OpenAPI definition for the product API. So what we will do is we will run the stub. So the simple thing is, against this pragmatic.jar, we will call the stub command, and we'll give the path um, to the spec file, and let's run it. Let's see what happens. So wow. So the stub has come up. So what it says is the stub server is running on port 9000. Let us go to Postman and try to hit this. So we are on port 9000 products, and we are giving it the same HTTP request that we have carved out here, that we have called out here. ID2 iPhone gadget 5, ID2 iPhone gadget 5, and let's see what we get. Okay. So here's what we are getting. So we are getting a timestamp of 23rd March 2021. And that's what we have given here. Okay. So so we don't have product API running right now, but still, we are able to emulate it by using this stuff. Okay, it works fine. But now let's try to make a small change. Let's say in this post product method, we add one more field called price, and we give it a price, let's say $200. Let's say 200. Okay, we save it. Let's see what happens here. Okay, let me rerun it. Okay, so what does it say? So it says product.json, the stub JSON didn't match the OpenAPI spec. Error from contract, and this is the error. And key name price in the stub was not in the contract. Now the issue is, this price key that we added here, was not there in our OpenAPI spec. Because it was not there, if you would see, this is the this is the request body and request schema, body of the request. And here we don't see any price key here, and which is where our stubs are not matching the actual API spec, and hence these are not reliable. To make them work, possibly what we can do is, we can we can uh, we'll have to correct it basically. What works? We can have multiple stubs as well. I can have, this is a product JSON. I can have another one. Let's try it out again. Let's say I've just duplicated it in the interest of time. Product Mac. Let's say it's a Mac. Okay. Name MacBook Pro. It's laptop. Inventory is 10. Okay. Timestamp is 2022 June 24th June 2022. Okay. Let's say this is the new stuff that has come up. Okay. And let's go to Postman. So I've copied this request. Okay. I go here, or should I duplicate it? Let me duplicate it. Let's see what happens. Okay, so here's this another product. So which is we get this product for MacBook Pro, which is 24th June 2022, and here we got a stub for iPhone. This is 2021, and that's how simple it was. So you can have your own stubs called out, and these stubs are matched against your OpenAPI specification and validated whether they are reliable or not. As simple as that. Okay, super cool. Moving on to the next bit, which is the backward compatibility check. So how do we? So let's say there is this product's OpenAPI spec, and we have carved out a newer version, and let's say we call it V1. I've just duplicated from the earlier products YAML, and this is, let me stop this. Okay, this V1. So let us do a small change here. So what could cause backward incompatibility? So one of the things is, let's say if I introduce a new mandatory parameter in the request, or if I make an optional parameter as a mandatory parameter, in the request, that will ensure that my new changes are backward incompatible. Okay, so let's say there was this parameter type which was nullable. I am calling this as non-nullable. Okay, but I am not sure whether this change is backward compatible or not. So what I can do very quickly is I can run this another command or this pragmatic called compare, where I'm comparing products.yaml with the new file called product v1.yaml, and let's see if our changes are backward compatible or not. And what it says is, this is so what it says is, in the request body type, this is string in the new contract, but it was nullable in the old contract, which tells us, which is why the newer contract is not backward compatible. So this is where, whenever we are making changes to our APIs, we are comparing it with the earlier OpenAPI spec, and this can clearly tell us whether these are backward compatible or not. And these checks can ideally be enforced at the time of, you know um, uh, check-in on the provider side itself. So let's say when the provider guys are making changes to their code, as they check in, firstly we can have the contract test being executed, and once the contract tests have been executed, as part of the PR request itself, now the which means the OpenAPI spec, the new OpenAPI spec holds good, and then you compare the new OpenAPI spec with the existing one and see if it is backward compatible or not. And once it is also backward compatible, then you allow the changes to be merged in your repository, and that's how you have shifted left from a place where you were running integration test cases and then coming to know about the possible gaps, versus versus now when you're coming to know even before you have checked in or merged your code with the repository, so that's a huge effective approach as compared to the earlier one, and this is what allows us to shift left and help us drastically. So with this I would close my session, open for questions and answers. So feel free to chime in with your interesting insights or comments or questions. Thank you so much, folks. Thanks a lot.
Thanks, Devesh. This talk was indeed insightful. Next up is Jocelyn Andrades, Director of Test Automation at Axel Q. Gio is an evangelist, community builder, and a renowned speaker, covering diverse topics including AI, no code, test automation. Giosle is going to share his thoughts on the in and ang of AI in testing.
Hello and welcome everyone. Hope you're having a great time at the conference and you enjoyed the last talk dealing with API chaos. I'll be talking about the yin yang of AI in testing at this QuantNext conference by Globant. I'd like to thank the team for giving me an opportunity to present at this insightful conference. So let's get going. Let's get started. About me, I am Jocelyn Andrades, Director Product Evangelist at XLQ. XLQ is an AI-powered test automation platform on the cloud, and I also lead Q Community, which is a community of global test automation enthusiasts. I have in all 15 years of experience. I am a certified AWS Solutions Architect, Scrum Master, as well as a certified Agile Leader. So let's get going. And before we delve into the topic of AI and the pros and cons of AI, let's just quickly talk about what is AI. So artificial intelligence, as per given by Mervyn Minsky, is the science of making machines do things that would require intelligence if done by humans. Now, whenever we come across AI, we hear terms about artificial intelligence, machine learning, and deep learning. So let's quickly understand around what these actually mean. So when we talk about artificial intelligence, it is basically enabling computers to mimic human behavior. A subset of artificial intelligence is nothing but machine learning. Now, what is machine learning? Is using statistical methods to enable machines to improve their experiences. And when you drill down, we have deep learning, which is a subset of machine learning, and this uses algorithms inspired by the function of the human brain. Now let's look at the evolution of testing, and this is a report from Gartner where it talks about the evolution. So in 1980s, testing started with mostly things being done manually. In 1990s, there came early test automation concept that grew in. In 2000s, we had browser automation frameworks come into place. In 2010, DevOps kind of started evolving, and there came the rise of what we call continuous testing. And in 2020s, now we see a lot of AI augmented testing being used and incorporated in platforms. Now, this is really very essential. As you see, the time of delivery cycle has kind of significantly reduced when it comes from the yesteryears or the past years, right? And you can see technological complexity and the change rate also increasing, and there is a huge demand for testing efficiency, and hence the need for AI augmented testing tools. Now, looking at the stats, and this is from Forrester, which was a commission study in association with Keysight, where it talks about 84% of the testing decision makers say half or more projects are either complex or multi-layered or have integrated systems. But to our surprise, only 11% say that their organizations fully automate their testing using AI for integrations. Now, this is a really small number as of today, but if you see in the next 3 years, 45% of these organizations are considering to use AI in their automated testing approach or in their integrations. So, this is a significant number, and the adoption and the demand for AI and automation will ever increase. Now, when we talk about AI, AI is everywhere. It did not just start with the inception of ChatGPT. AI was even there before ChatGPT came into picture. Now, what are the various use cases where AI was already there, right? So AI, if you see, has already been there in assistants like Alexa, the Googles, and the Series of the world, right? You can see AI even in video recommendations, the likes of Netflix, the likes of Amazon Prime, where you get personalizations and curated videos as per your interest. Then we have seen AI in image filters, or video filters that we have been doing. So there has been a significant use of AI there as well. Not far behind, you can see the adoption of AI even in weather forecasting, pest detection, soil and crop monitoring. You can see the use of AI in face recognitions. Mobile phones today already have face recognition softwares installed in them, which are driven behind the hood using AI. We do have AI also used a lot in the medical industry, in cancer detection, in medical imaging, or in cardiovascular risk analysis. So AI has been there for a very, very long time. The popularity and the hype that ChatGPT has created has accelerated the importance and the popularity of AI. Now, why this has been primarily done is because you have AI in your own hands. You can use the power of open APIs to run and do wonders, use and achieve various use cases with AI. So let's get to our topic, and we are talking about leveraging AI in software testing. So where all use cases we can use AI, right? So we can use AI in element identification. We can use AI in action logic creation, in discovering new tests, visual testing, self healing, test data generation, and result collection. So in today's talk, I'll be covering about these 7 use cases, but the advancements are so rapidly progressing that there will be tons of use cases that would come into the future as well. So let's get started and deep dive into each of these 7 use cases of how AI can be used in software testing. So the first one is element identification. Now, whenever you automate any test, you basically need this prime component of what element you need to interact with. And for that, element identification is really, really very important. Now, traditionally, when you were doing element identification, you would have observed or you would have to do basically the help or take help of developer tools, right? To get the XPaths, to get the CSS selectors, to get the IDs, to get the names, etc. If not a developer tool, you might be using some browser plugins to do this for you. Now, this can get a little bit more exhaustive and may lead to a lot of maintenance issues. Now, and one more thing is very precisely that not always you will have test automation or test engineers experts in building XPaths and CSS selectors. The complexity increases when you get elements like shadow DOMs or iframes or dynamic elements, and this can be a very tedious process. So, in order to solve this, why not use AI? Today's modern technology and use of AI automatically parses the entire DOM structure on your screen and gets you the various element identifications without worrying about what the XPath and CSS selectors can be. There are other modern platforms today as well, which kind of identify these elements using images. So there are various use cases on where AI can be used for element identification, making it easy for a test automation engineer to identify this and use them in their automation. So showing you a quick demo of how this AI works, I've used an open object detection API. Here is an image of the savanna forest where it's identifying the animals here, the zebras. This is an image of a football ground where it's identifying a sports ball and persons. And here you can see this API, which is of an airport, which is detecting the plane, aeroplane, the truck, the bus, etc. Right? So algorithms can be useful in finding objects, just like you can see here, to find out, the objects on the screen as well, which you want to interact with. Now we have talked about, yes, this has been a problem. This is a solution where you can use AI to do or detect object identification, direct paths and CSS automatically. But what's happening behind the hood? So basically, behind the hood, there is a lot of AI algorithms that are being used. The most popular one when it comes to element identification is decision trees. So I'd like to brief you around what this kind of actually does. So when you talk about decision trees, we have a decision node, then we have a subtree which has a decision node and various leaf nodes. On the right hand side, if you see in layman terms, if you want to understand the concept of decision trees, it is basically you are given a basket which is filled with apples, oranges, and cherries. Now you put in a condition that, okay, I want the fruits which are only greater than equal to 3, right? So my objective is to identify an orange, right? So the first validation I put in is the diameter greater than or equal to 3, right? Now on this decision, we have a leaf node which is false and true. So the false one will store all the cherries in, and the true one will have the apples and the oranges. Now we want to further filter this down. So we add another decision there, which is the color orange. And here we are able to split and identify the exact fruit that uh, we want to have or deal with, right? So this is one of the algorithms. The another popular algorithm that is used behind the hood when it comes to element identification, and it's very important for you to understand when platform claims to do this, they kind of talk and behind the hood should be aware of these kind of algorithms as well, right? So this one is specifically KNN analysis, which is called K nearest neighbor. So whenever you're trying to identify an object, so let's say, for example, in layman terms, we are trying to identify this grade image, right? And we are trying to identify what this could be. So in KNN analysis or the nearest neighbor, it kind of identifies from its previous data set what are the probable nearest neighbors. So in this example, which is a simple example of Tom and Jerry, it kind of identifies that we have one count of Tom and two count of Jerry's, which are nearest to the element or the image that we want to identify. So in conclusion, because our data is showing that the probability of it being cherry is very high, uh, we can assume, and the algorithm identifies that yes, what you're trying to identify is nothing but cherry. So this is more to do with element identification. Now let's talk about action logic creation. Now, whenever we look at testing and whenever we look at writing action logic in testing, right, and whenever we look at automation, traditionally we have been doing a lot of test automation with code, right? There are a lot of dependencies that you need to import. There is a lot of code that you need to write. So you need to write code in Java, C Sharp, Python, Ruby, etc. In whatever traditional frameworks that you use for automation, right? Now, yes, of course, not everyone is an expert. Not everyone is a coding expert. Not everyone likes coding. Now, why deny someone who is not a coding expert to automate? That's where you can use the power of AI to automate. Now, modern technological platforms today can help you author and write your test using AI in specifically no code or in a codeless fashion. So here I'm doing a simple step of logging into a platform using just 3 lines of code. There are platforms which kind of also interpret what you're trying to do. So in the right screenshot, if you can see, I'm trying to type print, but it's kind of giving me suggestions of what I actually need to do with regards to this. So print, it's kind of platform is auto suggesting using its NLP algorithms that I want to probably log an info message, I want to log an error message, warning message, pass message, etc. So what's happening, and this is a quick demo of sentence similarity. I talked about how does the platform kind of predict what I'm trying to do and what's all the AI and the NLP all about, right? So this is a quick demo with regards to just again Open API, which is sentence similarity API. So I've given a sentence, this is a happy person, and I've asked it to compare with three other sentences, like this is a happy dog, this is a very happy person, and today is a sunny day. So the AI algorithm skims through the keywords and tries to find out the probability of which command is higher. So you can see here the sentence, this is a very happy person, has a 94 probability that it is similar to the sentence or my source sentence. So this is how the algorithm intelligently identifies what a person is trying to recommend. And that's what we call today truly no code using the power of AI. So what's happening in the background? We have been talking about and what's actually and how and what goes behind a platform to generate such kind of no-code uh, suggestive algorithms for you or suggesting action logic for you, right? So it's basically using NLP, which is divided into two, which is natural language understanding, also called as NLU, and NLG, which is called natural language generation. So if you look at lexical ambiguity, which is a part of NLU, which is when a word carries a different sense. Now, if you look at this example, he is looking for a match, right? Uh, Here, you need to understand what is a match. It could be a partner, it could be a cricket, or it could be a football match. So the algorithm needs to be trained to understand what you're trying to refer to. The other thing is also syntactical ambiguity. Now, if you see this example, and when we talk about syntactical ambiguity, it's when we see more than one meaning in a sequence of words, right? So, for example, if you see Feluda met Topsy and Joytu and they went to a restaurant, right? Now, who is they being referred to here? Is it Topsy and Joytu, or is it everyone, right? So, this is something that the algorithm also needs to identify. The other aspect is referential identity, and very often, like text mentions an entity and then it refers to it again, and possibility in a different sentence or in a different word. So what is it trying to refer and what is being referenced here is basically called referential ambiguity. Now, for example, this example that you see here, a brick fell on the computer but it is not broken. Now, what is it here? Is it a brick or is it a computer? So this is one part, which is NLU, and then we talk about NLG, which involves text planning, sentence planning, and textualization. So given the keywords, so in this example, you're giving keywords like line M012, direction Herald Square, vehicle bus departure, time 9:01 a.m. from stop Wall Street. Now, in text planning, what happens? It includes and checks the relevant content in its knowledge base. And in sentence planning, it kind of forms those words, forms the meaningful phrases and the tone of the sentence. And in text realization, what happens? It is maps the sentence plan into a sentence structure. So here, given the set of inputs or the parameters, it's kind of formulating what that particular sentence would actually mean. So here it means that there is a bus at 9 a.m. from Wall Street to Herald Street, which is using M102. So this is the powerful way of using natural language processing to generate, uh, code or author code for you. Now, we'll be talking about, and more importantly, ChatGPT has been in talks for quite some time now. So even generative AI, for that matter, even if you're not going with a codeless option, you still have generative AI or ChatGPT generate the exact traditional code for you. So here I asked ChatGPT to write a Selenium code for me that opens a Google Firefox browser, searches for what is ChatGPT, and wait for 3 seconds. So here I just ask ChatGPT this question, and it's going to generate the code for me itself. So while we have AI, which kind of helps us with no code and generating, or authoring us in codeless language, here you can see an example of generative AI, which is actually generating the traditional Selenium code for you, right? So this code is specifically generated in Java. It kinds of identifies and writes the code for you and explains and gives you an explanation of what it has written. So I've asked it to go to Google, type in what is ChatGPT. Now I'm pasting it in a ID and I'm running this Python script, which is very simple. It just goes to Google, opens ChatGPT, sleeps for some time, and then it kind of quits. So we try to execute this, and I try to test, whether things from ChatGPT really work, right, and the code actually works. So here you can see that is kind of executed. It now opens up the Firefox browser, uh, runs your code, types in what is ChatGPT, and voila, you have it there for you, ready, right? So these is also a very good use case of how you can use generative AI as well in your test authoring as well. Now, one thing you need to realize that this is very context specific. If the website is your specific website, the element locators may not suit you, right? Hence, we talked about the first place where using AI to automatically identify the elements can also aid you to author test really faster. So don't fall into the catch today. And days before OpenAI, developer coding kind of took like 2 hours and debugging took 6 hours. And the irony today is, ChatGPT kinds of generates a code in less than 5 minutes, but developers spend 24 hours in debugging it. So be careful and use the code generated really wisely. Now let's come back to the third aspect of where you can use AI. And this is a very interesting aspect, which is discovering new tests. Today we have testers, and why not have machines as well hunt for corner cases, right? So what has happened traditionally, right? Traditionally, we have been using an Excel file, right, where we have our steps, our description, our status, expected and actual result. Now, this is something that we have been doing quite manually. We have been writing our test cases, and then later on we are going to test it. We are mark pass or fail, and go and do things ahead. Now, very surprisingly, the modern way of how things can be done today. So this is an example of agent, which is AI generation exploration in test. And if you want to explore this project more, you can go to GitHub by Tariq King /agent, and you will be able to see this particular project and learn about this project, right? So this project specifically, evaluates all the actions, fields, and forms on the page that is open, and it kind of automatically executes it for you and runs the result automatically. Now, this is really cool. So we talked about it, and we see things happening really well with AI, and seems interesting. But what's actually happening here, and what's happening in the back end? So what is actually happening here is you're trying to train a neural network model. Now, training a neural network model, and this is a source from the research article from ACM Digital Library, which talks about training the neural network models using three actions, which is perceive, act, and observe. So let's take an example of the login screen we have been talking about. So the login screen, the perceive action is, okay, identify what's on the page. So the network model identifies that, yes, this is a login screen. Now, the next thing is basically to act. Now, act is what all actions can I do on a login screen? So, for example, I enter my username, I enter my password, clicking on a sign in button. These are the actions that can be done on that screen. And then the next part of the neural network model is observe, which is what actually is happening on that page after that action is performed. Are you trying to see error messages? Are you getting a success message? Is it landing to some other page? So these are the things of how a neural network model is trained, and that's how it can discover new tests. So giving the example on the right hand side, if you see here, you can see an example. This is basically the first name and the middle name field that we have as input text boxes, and the save button. Now, when you perceive, it's basically observe. The model kind of observes that, okay, hey, there is a text box which has first name. Now it kind of acts. So it tries to, enter the valid first name, then clicks on commit. And then obviously there should not be any error message because first name is mandatory and that's what we expected. But the dynamics kind of change if you keep first name blank, because since first name is mandatory, the model should observe that it's an error message. So this is how neural networks model are trained, right? Now, text box middle name is kind of can be blank because it's not mandatory. And once you click on save, you should not observe an error message, right? So this is how the model kind of automatically triggers the test based on what it perceives, what it is trained to act upon, and what it is trained to observe upon, right? Now we're talking about this, and as a theme of the conference is also on generative AI. Here we are talking about again how you can leverage Chat GPT if not training the the neural network model. So directly accessible with Chat GPT is you can ask the generative AI Chat GPT to write test cases for you. So I asked a simple prompt, which is write test cases to test a login page with username, password field, and login button, right? And there goes, you can see that Chat GPT was able to identify the positive test cases, the negative test cases, and give me various combinations of what we kind of did now. So while you can see the discovery mode, which I talked about, even Chat GPT kind of explores and gives you various combinations itself. So this is one other good way you could leverage generative AI and Chat GPT as well. Now let's talk about the fourth point, which is visual testing. Now, visual testing is very important, right? Most of us kind of traditionally have been following and doing only functional tests, ignoring the aspects of UI and UX for a platform. But what we need to understand is that UI and UX is important. Any user or any client which is coming to your platform, if the UI is not good, if the UI is not laid out properly or is not visually correct, they will just turn off and go to some other platform or go to some other app, right? So it's very important for us to incorporate visual testing. And how visual testing has been done traditionally. Traditionally, visual testing has been done using pixel to pixel comparison, right? So basically, a pixel on the right and the pixel on the left, if they match, it is a white. If they don't match, it's a red. So you can see that example I've shown here, where some things which don't match are red in color, right? Now the problem with a pixel to pixel comparison or bitmap comparison has been the problem of anti-aliasing. So if you can see below the playlist, it is just moved away by 1 pixel. But when you do a pixel to pixel comparison, you see that everything is red, right? Or everything kind of errors out or tells you that it's not visually correct. So that's where traditional ways could not be correct, and you need to use AI in these cases. Also, traditionally as well, there have been certain cases where engineers have been testing visual elements using assertions. So say for example, you have a screen where you have icons, text, button, etc., and you're trying to add visual checks like, is the button visible, at what xy coordinates are they, what is the height of the button, what is the width of the button, what is the background color, etc., etc., right? Now to write this assertions, right? You're writing like for 20 visual elements on the page, 5 assertions per element, you're writing 100 lines of assertion code. That is really, really very huge, right? And now if you go and run this code or want to run this code on 30 different platforms like OS, browsers, and mobiles, you're looking at writing 600 unique configurations. Now that is not it, right? If you have app, if your app has 100 different screens, and let's just take that you have just validating 20 visual elements on each screen, you're looking at 60,000 unique configurations. This is a pure overhead to do using a traditional style. Now why not use AI for such kind of visual testing? That's where modern ways of testing come into picture, where even if that difference is not visible to your eye, your the AI is intelligently able to predict and give you that difference. So you can see this image, it's very difficult for an eye to predict what the differences are, but when you use AI models or the concept of computer vision, you can easily detect the differences. So I'll just give you a image classification demo and what's actually happening using computer vision. So this is an open API, which is image classification API, where it's trying to kind of identify what is this image. So here is the image of teapot. Here you can see the image of a palace. So this image classification AI API is kind of trying to see that, okay, hey, the image that you're showing here has 99% probability that it is a palace, right? So there are other disturbances or noise around that image as well. You can see a garden and stuff like that, right? But it's kind of trying to identify based on the AI filters that it has in place that yes, 99.7% probability that this particular image is of a palace, right? Now we talked about it, and yes, we can see significant benefit of using AI for visual testing, because even some minute errors which our eyes cannot see, AI is able to do that. But what's happening behind the hood is basically it's using the concept of computer vision, right? So each pixel that is comparing has the values from 0 to 225 depending upon the shade. So in the black and white, you can see that this is a face that you can see of Abraham Lincoln, where you can see roughly the, in the black and white image, how the pixel values are saved. Now the complexity and the the AI algorithms of computer vision increase when you are trying to compute and compare color images, right? So if you look at the concept of RGB, which is red, blue, and green, each pixel now in a colored image has to save three different values, again from 0 to 255, right? The other aspect is also when it is dealing with this kind of visual predictions and visual ambiguities in your images, it's kind of doing the concept of convolution and polling, right? So in this image, if you see, this is an image of a boat. What happens is it's kind of using its own filters to find out what each section of this image is. And then after the polling is done, it kind of forms a fully connected model of information and then predicts what this image actually is, right? So here you can see that it's predicted that the boat probability that this image is a boat is 94%, right? So this is also what is used behind the hood when we talk about AI using visual testing. They kind of, or these platforms use what we call computer vision, which is really good and really helpful. Now we talk about the fifth concept, which is of self-healing. Now, self-healing is really very important, and we have seen the struggles now when it comes to the latest of tools, right? And delivery, like I said, is going really fast. Most of the modern tools today deploy every second. Some of them deploy every week, every month, right? So the pace of delivery has increased, and if some object kind of changes, it becomes a huge problem to maintain an automation test manually. So for that, in the traditional way of how self healing was done, was it was very much you know very basic in using simple if else loop, right? So if this is a release, use this X path. If this is the release, use this X path. Or there were different repositories for different releases. Now this was not feasible, right? Today releases happen so quick that to edit your code, maintain different repositories is not very viable. So for this case and the modern way of things, why not use AI? Today there are self-healing algorithms which kind of tell you what has changed in the image and auto-heal the script so that they do not fail. So platforms have become really modern today. On the right hand side, you see an open source Selenium extension which is called Selenium, which also uses the concept of self healing to heal your Selenium test and automate them, and if there are any object changes, and proceed further. So this is very important of one way where you can use AI and self healing algorithms, which actually showcase its true power and heal elements and prevent you from any sort of release change, element changing errors that you might get. So what's happening behind the hood and what's the AI all about in this self-healing, right? So it's basically using multi-class and multi-labeling algorithms. So multi-class is basically, it's kind of telling you one input class at a time, and multi-label is producing multiple output classes at one time. So if you see this example of a dog in a tree, when we say multi-class, it's kind of trying to identify what is the most prominent thing in this image. So it's kind of predicting, yes, this is the dog. In multi-label, what it is doing is it's kind of asking or identifying what are the elements that are highly probable and seen in this image. So there you see uh, a dog, and there you see a plant. So this multi-class and multi-label algorithms are used to self-heal and identify objects or similar objects to heal and proceed your test automation steps with, right? The other popular algorithm that is used behind the hoods is K-means clustering algorithm. So when we talk about elements, right, how does the algorithm or how does the platform understand, what element to heal and which element to interact with? So it kinds of use unlabeled data, and then you use the k-means clustering algorithm to label the data. So we're looking, and if I want to talk in terms of a layman language, you see here this is a collection of birds and animals, right? Birds and fishes, sorry. And once you apply this algorithm, it kind of gives you labeled clusters. Like, okay, these are the set of fishes, and these are the set of birds, and this is how you can interact with these elements. So the next use case is test data generation. Now, test data generation is really, really very important. And traditional ways of test data generation and dealing with data, we have used like random test data generation classes. We have used the concepts of jQuery APIs in Java. Now, this can get overwhelming at times, right? To write the code and to generate data. Now, why not use uh, the modern ways and modern techniques of AI? So modern platforms today automatically generate test data for you, automatically generate the possible test combinations for you. So here, if you see, you can see, uh, you know, the destination origin service class are the test data which are automatically generated with this set of combinations. So let's look at a demo, and I've used here field mask API. Now here I'm asking Paris is the dash of France. So it's kind of automatically using the AI API to kind of figure out, okay, I might be referring to capital, which has a 67 probability that it is right. Now here is another example. The goal of life is dash, right? So the algorithm kind of skims in and finds out, okay, what is that data which could probably fit in here. Now here you can see that, okay, happiness could be a probability that is the highest. So it's kind of recommending you certain sort of test data which uh, is the true power of AI, right? Now behind the hood, what is being used? So what is being used behind the hoods is nothing but generative adversarial networks, or what we call GANs. Okay, so what is happening in this basically generative model? Uh, the generative model has been given sample training samples, and when you put an input saying, "Hey, I want some random number or a random data," it looks at its training samples and kinds of parses it and gives you the generator sample. So here it's giving you a number 8. The other thing that comes into when you talk about test data coverage and covering maximum possible combinations, right? So if you have 4 possible inputs in one element, 4 possible inputs in the second element, the number of test cases that you can do for these two possible combinations is 4 cross 4, which is 16 different combinations. So test data generator also uses combinational permutation, and these programs use this behind the hood to generate maximum coverage for your test cases, right? So again, coming back to the powerful nature of what ChatGPT has to offer today, ChatGPT also offers you sample test data generator. So here is an example of generative AI doing this for you. So I asked ChatGPT give me 10 rows of sample test data which contain name, email, phone number, city, and state. And here you can see very powerfully that it's automatically generated this information for you for use. The other thing I also asked ChatGPT is more about generating pairwise test data. So you can see here there is a variable 1, 2, 3, 4 in variable A, and variable B has values A, B, C. And I asked ChatGPT to generate me various combinations of this pairwise testing information. And here you can see ChatGPT has generated me the various combinations and use of this data. So you can see here it has generated me 9 combinations of test data for you. So this is also a useful way where you can use generative AI to generate test data as well, along with other platforms which are providing this for you. So the last step and the last use case that we're talking about is result collation. Right? Traditionally, results have been maintained again in Excel files where you execute a test and you write a result. Right? Now, this has been very, you know, very not very attractive when it comes to showcasing the width of what your tests have done, right? And are not very intensive and rich in nature when it comes to looking at an Excel file, right? So with the use of AI, you can get modern result generation dashboards, right, which talk about your execution status, which talk about defects identified at each stage, which talk about what is your test coverage, what is your test suite readiness, and other various factors that are there. So I just giving an example of result collation. So this is basically a summary of a text. I'm using a summary, AI API, where I asked it to summarize the text of code and give me a short summary of this complete paragraph. Now you can do this in ChatGPT as well, where you can ask ChatGPT for a summary, right? So what it is doing basically, it's collating your test result into one. So here, what is happening behind the scenes, it is using hierarchical algorithmic clustering, which is also known in the AI world as hack, right? So each of your individual data points are clubbed in a bottom-up approach to give you a collative result, right? So this is the algorithm which is used behind the scenes when you talk about hierarchical algorithmic clustering. So, just to summarize my talk, we talked about element identification, where we are using decision trees, KNN analysis, action logic creation, where we are using natural language processing, discovering new tests, where we are using and training neural networks, visual testing, where we are using computer vision, self-healing, where we use multi-class and multi-label algorithms and claim-in clustering algorithms, test data generation, where we are using GANs and combinational permuting algorithms, and result collation, where we use hack. So these are the wonderful use cases where AI can help us get going. So we talked about all of the goodness, but definitely artificial intelligence or AI can also go wrong. There are various use cases that you can see. One of the popular ones was the Microsoft AI chatbot Tay, which got trolled, and less than 24 hours, Twitter had to pull the chatbot down because it kind of started giving unnecessary comments and tweets. And of course, Uber self-driving cars had also gone wild in back in 2018, where they kind of the vehicle or the self-driving car hit a 49 aged woman. So yes, AI can go wrong. Not all AI is good. You need to use it really, really cautiously. So there comes the big question, and we all are afraid of, or we all kind of ask, will artificial intelligence replace testers? From what I know, AI will not replace testers, or it will take us a lot of time for AI to actually replace testers. But definitely, a tester using AI will replace a tester not knowing about AI. So it's time that you learn about AI, learn about techniques, and embrace this concept of using AI for your benefit. And that's not just me talking about it. And there is still testing which is going to have value. If you see the recent use case where Google's AI chatbot Bard, which went wrong and got like 100 billion loss into the market for Google, in their press report they highlighted the importance of rigorous testing process. So testing is not going away, testers are not going away, and Google CEO himself recommends his staff to spend at least 2 to 4 hours testing their chatbot Bard. So we are all still going to be relevant in the near future. And this is an interesting board that I came across visiting one of the conferences, which talks about, hey, chat GPT, finish the building. But one thing you need to realize that AI is not magic. It will have its limitations. So your skills are irreplaceable, and the human mind will always be superior at all times. So, in conclusion, AI is neither good nor evil. It's a tool, it's a technology for us to use. So, embrace AI and use AI, and where you can enable humans to focus on their path and role that add most value. Hope you found this webinar very interactive and learned a lot about AI. If you have more questions, I'll be happy to take them or chat, or you can connect with me on LinkedIn, Twitter, and uh, get going and learn more about AI, and we can discuss more about other ways and other use cases how AI can help. So I'd like to thank the team for giving me this opportunity. See you and hope you enjoy the rest of the conference. Namaste.
Thanks a ton, Gio. The talk was absolutely fantastic. Thank you, everyone, for such an inspiring day. With this, we wrap up day one of Globant QuaNTA NXT 2023. I look forward to seeing you tomorrow. The details are in the description below.